Hello, everyone, and welcome to a best practices video on using Snowflake with Test Data Manager. I'm Pamela Deesa, the marketing manager for all the DevOps products here at Broadcom. Today's video is going to be hosted by Satya Mahante, who is a customer engagement engineer and expert on Test Data Manager. If you're not familiar with Test Data Manager, it allows you to create a subset of production data while masking all of the PIR data elements. It also allows you to create synthesized test data, which of course doesn't require masking. Today, Satya is going to share with us his knowledge of Snowflake and also share a short demo with us. So for now, I'm going to turn it over to Satya.
All right. Thank you so much, Pam, and good morning, good evening to everyone who's listening in. So, today we have a really exciting topic for you. We will talk about some of the improvements that have introduced kind of recently with our TDM suite of products, with specifically with regards to Snowflake. So, as we know, Snowflake as a database usually will contain a very large amount of data. We will run into scenarios where customers might have billions and billions of records, many terabytes worth of data. And traditionally, in the past, when we were doing masking using Snowflake, we had some issues with the performance, which we have upgraded significantly. And we have a new version of TDM coming out, which we'll talk about more in today's session. The version of TDM that came out with 4.11.50, everything prior to that, we always did support masking with Snowflake, but there were certain challenges with it because, as we know, fast data masker, because the masking engine both in FTM as well as in the TDM portal, it is mostly an in-place masking utility, which means masking will place more as an ELT transaction, masking it in place rather than ETL transaction and masking it on the fly. And as a result, what happens is databases, for example, Snowflake, which is much slower to mask as an update transaction as compared to an insert transaction, does not perform well when asked to perform masking via a FTM and update transaction. And as a result, what used to happen was when we were using TDM prior to 4.11.50 to perform masking, the update transaction based FTM masking used to take almost 2 hours to mask 10K record, which was, of course, very, very slow. We did introduce some incremental upgrades in one of our 4.11.50 prior versions, as part of which we were able to perform using the generator based clone approach to essentially mask data by performing an insert from a source to a target and performing the masking in flight as we're moving the data from a source to a target using the TDM portal. Even with that approach and using some other additional upgrades and bulk masking techniques, we were able to bring it down to around the same 10K records to mask under 10 minutes. But it still did not solve the bigger problem, which is customers who have billions and billions of records and many hundreds of tables containing large volume of data. This was still not good enough. And that is when we introduced a upgrade as part of 4.11.50 and beyond, which means you have to have installed fast data masker 4.11.50 or newer and be on a newer version of the portal as well. That will enable you to get access to some of the newer capabilities of how we can perform masking for Snowflake with TDM and FTM. Now, what this capability does for us is essentially, as we know, Snowflake with its unique challenges, that a database which is not really designed for update transactions but more for insert transactions, we have introduced various 3 or 4 different ways of how we have been able to make masking much more efficient. The primary one starts from the fact that now with this new technique, we are using Snowpark libraries, and rather than the older version when we use the direct Snowflake JDBC connectors, even the Snowpark behind the scenes still uses Snowflake JDBC libraries. But Snowpark is a much quicker way to perform insert transactions and data movement within the Snowflake environment itself. Using that, what we have done, we have introduced the concept of where the FTM engine or the TDM portal via FTM is going to essentially create a temporary table where the data would be sort of moved from the original table. And as the data is moving, the masking will happen in memory and get inserted into this temporary table. Now, when the original table is updated back with the masked results, TDM/FTM will perform an insert merge. Now, as a result of the insert merge, along with the introduction of the temporary clone table, which gets created in the backend, the result is a significantly quicker way of doing masking. At the same time, a couple of other key things that we've introduced here starts from the batch commit. Right, earlier the batch mode had to be enabled specifically and had to span all of the tables of a typical portal based delivery. But in this case, depending on the size of your Snowflake masking, we have been able to perform a batch commit, so that by default, if your number of rows per table exceeds certain amount, so the batch commit is getting performed by default. At the same time, we also have the large table split enabled capability, which earlier used to be the purview of only Oracle SQL and a couple of other databases. So we have also enabled the large table split, which together with the batch commit, with Snowpark libraries, and the insert merge capability of Snowflake, we have been able to essentially significantly improve performance to the tune of, without a large table split enabled, the average masking time for about 1 million rows takes about 3.5 minutes. And for large table split enabled scenario, we are able to mask the same 1 million records in about 1.5 minutes. Now, there are some key considerations that we should be aware of as we are deploying this sort of a masking technique, which include the fact that the temporary merge table that we spoke about, that table will get created in the backend, and upon a successful completion of FTM, this temporary table will get deleted. Now, in the case of a failure, if FDM for some reason fails or TDM portal for some reason fails during the masking process, this temp table will not be automatically deleted. So you have to be cognizant of the fact that in the case of a restart, make sure that you delete or purge your temp table, or you might have to manually delete or purge the temp table before you restart your masking, right? Or while it will still create another temp table if a temp table is already existing. It is a best practice that making sure to delete your temp table before you restart your masking. The other important consideration is, while you're performing a masking, it is always a best practice to take a backup or a copy of your original data, right? Because typically FTM is, or TDM portal via FTM is an in-place masking utility. So we have given an additional capability for you to take automated backup of your original set of databases and tables, rather table or tables, by using this clone functionality. If you enable this clone functionality, which is a default behavior, for every table which will be masked, FTM/TDM portal will create a clone table, which is there for your consideration. Again, you will be able to disable this functionality if you do not wish to create the clone table. The third key consideration is that when you have a very large number of rows with Snowflake, performing the commits with batch, as I mentioned, goes a long way to essentially make the overall masking quicker. The default behavior for a large number of rows, the batch updates is automatically enabled, is basically 5 million. This can of course be configured as part of your masking options, and this is definitely encouraged to be used as you get to very large volumes. Same goes for large table split as well. If you're going into many millions of rows of table, or many tables with very large number of rows, enabling the large table split would be a definite improvement of overall performance. While this is happening, some of the new options, masking options that have been introduced in FTM and the TDM portal include these 5. The first one is Snowflake huge data. So what this parameter does, Snowflake huge data, is when you have a large volume of data, specifically more than 5 million rows per table, it is automatically assumed to be huge data in TDM language, and the batch mode of update is automatically enabled. This can be updated in your masking options, of course, but the default behavior is for 5 million rows, we consider this as huge data. And batch updates are automatically enabled. Batch update size, it is defaulted to 1 million. Again, this is configurable, which means every 1 million rows, the data will be committed for every 1 million rows which are updated. Snowflake create clone, the default option here is Y, which is for every table which will be masked. In addition to the temp table which is required for the insert merge, a clone table will also get created, which is more like a backup of your original data, which can be disabled or dropped after your successful masking completion. The next option is for your Snowflake suffix clone table, which is essentially the suffix which is assigned to every table which is getting masked is prefixed with the default option of underscore TDM underscore clone. And you can, of course, override that as part of your masking options. And the last new option that we introduced is called the temp table prefix for the merge table. As I mentioned, every table which is getting masked, the insert merge, which will give us the performance for masking Snowflake, a temp table will be created for every table, and the suffix for the same will be a Snowflake suffix temp table with a thread ID, and the thread ID is an auto-generated numeric value, which is typically used to prefix and suffix each and every table which will be masked, right? So with that, we will do a quick demo as well for this capability and see how it looks. All right. So with regards to the demo, first I want to start off by talking about the TechDocs page, which has all of the new options which have been introduced as part of 4.11, 4.11.50 FKM and beyond. Right. So on this particular page, we have all of the supported data types, the available supported functions, as well as the few examples of how you would want to use those 4 or 5 options we spoke about, which is the TDM clone, huge data size, the batch update, and the 10 table merge ID. Yeah, right. So just a few examples that will give you a reference of how to go about doing this. The second thing is a little bit more details around the 5 new options which have been introduced. So that information is available on the TechDoc site. You can go in, search for Snowflake, and you will see the Snowflake masking page, which will have the examples for the masking and the options as well. Now, going on to the demo for today, we will do 2 small demos. One will be from the portal, and the second one will be the same one from FTM as well. So depending on your use case, depending on what you typically are used to, you can choose either or option. Having said that, with the TDM portal, Snowflake is compatible with all of the functionalities of the portal, which includes modeling, the PII audit, data discovery, the data masking, synthetic data generation, find and reserve, self-service, all those capabilities are available for Snowflake as well. It is not just limited to data masking, right? And in the case of Snowflake, as always with everything to do on the portal, we need to make sure that we have a connection profile created, right? Let's say in my case, this is the connection profile which I have already set up for Snowflake. And I'm gonna test to make sure that my connection profile works okay. So the connection works okay, and I have the right context set up for my project and my version. Once that is done, as always, I could create an environment. In the environment, I would be able to connect the environment to said connection profile. It could be more than one connection profiles, of course, as well, as is the case with the PDM portal. Once you have created the environment, you will be able to perform the scan of the data model. Once the data model scan is done, right, you will be able to see all of the tables which make up your Snowflake database. In this case, I have just one simple demo table. And once you have performed your data model scan, of course, you can also scan your PII data. The data model of the PII scan also again works the same way as you always would do. You would be able to select the right classifier packs for common and your geography. You will be able to select what level of scan do you want to perform with just the column names or name of column as well as the data. Select the level of scan if you need to store any match samples, and if you want to keep your scan to key based columns or not. And based on that, you can perform your scan and the result of the scan will look something, of course, like this, in which you will be able to see that the profiler would be able to associate a tag of a name for a first name and last name, a date of birth for a DOB field, and address for address lines 1 and 2, and city, state, and zip code for the corresponding table columns also. Once you are satisfied and happy with how the scans have performed, how the masking tags have been associated, you can then move on to the data masking. Here, you of course select your data model, the one that you want to mask. You will be then able to see the default data masking rules which have been associated. If you need to modify or change your data masking rules, you can of course do that. You can go in here. As you can see, the default hash LOB for the first name, and first name seedless has been applied for the both the first names and the last names. In this case, this was the first name. Here it was the last name. Same thing, we have the date of birth masking rules automatically applied, address line 1, the city, state, and the zip code. Right? All of this will come automatically for you. And of course, always, one added benefit of doing the masking from the TDM portal is you will be able to automatically see the data masking rules getting applied as long as you have performed your data model scan and your PII discovery scan as well. Once these options are set up and you are happy and satisfied with the masking rules applied, you will then be able to go in and apply your masking settings. So as I said, we have got 5 new options for Snowflake. So if I scroll down into the Snowflake or S section, you would see the Snowflake huge data. As you can see, this is specific for your batch commits. So if you have more than 5 million rows per table, this is automatically enabled and batch commit occurs. Then the size of the batch commit is by default set to 100,000 rows. Well, I would say 1 million rows, of course. And then you have the default ones is if you want to create a clone table. If you want to take a backup of your original table in a clone table and then maybe do some compare, so just make sure you have another copy of data with you. And you have the suffix for the clone table. The default is underscore the table name underscore TDM clone. And similarly, the suffix name for the temporary merge table, which gets created as the table name underscore TDM underscore merge underscore temp underscore the thread ID, which is an auto-generated column, right? So once you are satisfied with the options, and you can go and do a next. Make sure you select the tables that you want to mask. You can of course select all the tables for the environment or only the confirmed tables. Select the environment. In this case, my environment has got one environment, or rather one environment for my data model, and you will be able to select a masking scope as well. So you can choose specific data sources or the whole environment. And as always, you can choose to do the masking in a preview mode, which means more of a simulation mode. You will be able to see the masking output, but not see the actual updates on the Snowflake database itself. And once you do that, you select all of the options and you click on mask and you confirm. That will kick off the masking process. So in our example, the database or the table which I had selected was essentially this TDM customer table, which has a million rows, as you can see. This is a very simple table, which has, as we saw, as part of the data model scan and the PA scan, an ID, a first name, last name, date of birth, gender, address, city, state, and zip. So we have applied data masking to the first name, to the last name, to date of birth, address line 1, city, state, and zip. As we know, the masking is running now as we speak. And for these million rows, we are expecting that this should complete in about 3.5 minutes. So while we are waiting for the masking to complete in 3.5 minutes, we'll take a quick pause and be back once the masking is done. All right, so our masking job, as we can see, completed. So we masked a million rows, and it took about 3 minutes and 41 seconds, so about 3.5 minutes to complete the whole masking. So if we go on to this table and we do a kind of like a quick refresh, we can see that all of this information would have essentially changed. if you go back and do a quick refresh, and the data preview, of course, would have changed, right? Because all the rows are now masked for the first name, your last name, your address, city, state, zip code, so on and so forth. Now, the same can, of course, be done, as I was mentioning earlier in the call, from fast data masker as well. Again, make sure you have to have the right version of FDM. So 4.11.50 or beyond. And as part of that, on your FDM engine, you will be able to do the same thing, create a new connection profile, select the table or tables you want to perform masking on. In this case, I have my customer table where I have applied data masking rule for hash LOB for first names to the first name column and last names to the last name column. On the option, I have for my Snowflake options, I have said I do not want to create a clone table, but again, depending on a use case, you can leave this as a default Y as well. And as I've set up my data masking rules for the first name and last name and the options file, I can go ahead and save and run the mask. So I can save this and override the existing file for the masking rules and for the options file as well. And that goes ahead and kickstart the masking process. And this will run the exact same way as well, wherein it is going to go in, name the connection, run the masking for about 3.5 minutes and complete the whole process, right? So that is essentially how we are able to perform the masking for Snowflake from either the TDM portal or from Fast Data Masker. And that's all that I have for you today in our best practices for Snowflake performance improvements using Broadcom, TDM, and FDM. And meet you for our next session. And thank you again for listening to us. Thank you so much. Bye.
Thank you, Satya, for sharing your knowledge on Snowflake. And thanks everyone for listening in today. Be sure to look for additional best practice videos by our other product experts here at Broadcom. Bye for now.